Learn. Justifying every step. Every turn on a reliable map is backed by a clear signpost. Solving an equation works the same way. Every step must be justified by a named rule. In this lesson, you will learn the 5 justification tools for algebraic proofs, the addition, subtraction, multiplication, and division properties of equality, plus the distributive property practice, selecting the correct justification for each step in a proof. Identify a justification error in student work. Exploring the properties of equality and distributive property. These 5 properties are your justification toolkit for solving algebraic equations. Select each section to explore the property, its plain language meaning, and a worked example. Addition property of equality. Adding the same value to both sides of an equation keeps it balanced. Plain language. Use this to cancel out a subtracted term by adding its opposite to both sides. Example. Add 10 to both sides. Both sides gain the same value, so equality is preserved. Subtraction. Property of equality. Subtracting the same value from both sides of an equation keeps it balanced. Plain language. Use this to cancel out an added term by subtracting it from both sides. Example. Subtract 12 from both sides. Both sides lose the same value, so equality is preserved. Multiplication property of equality. Multiplying both sides of an equation by the same non-zero number keeps it balanced. Plain language. Use this to eliminate a fraction or a denominator attached to the variable. Example. Multiply both sides by 3. Both sides are scaled by the same factor, so equality is preserved. Division property of equality. Dividing both sides of an equation by the same non-zero number keeps it balanced. Plain language. Use this to isolate the variable by removing its coefficient. Example. Divide both sides by 9. Both sides are divided by the same number, so equality is preserved. Distributive property. When a number sits outside parentheses, multiply it by every term inside the parentheses. Plain language. Expand the parentheses without changing the equation's value. Example. The 3 is multiplied by both and 4, removing the parentheses. Recognizing other justifications. Not every step in a proof uses one of the properties just described. 2 additional justifications appear frequently. Given, the starting equation or statement accepted as true. Every proof begins here. No operation is performed. You are simply naming the information you were provided. Simplify. Combine like terms. When 2 or more like terms on the same side of the equation are added or subtracted together, for example. Because no operation is applied to both sides, this is not a property of equality. It is a simplification step and must be labeled as such. Key distinction. The 4 properties of equality, addition, subtraction, multiplication, and division, always involve performing the same operation on both sides of the equal sign. Distributive property and simplify, combine like terms, both apply to one side only. These steps always get their own separate labels. Walking through a proof. For each step in this proof, apply the 2 diagnostic questions below to identify the justification. Work through the reasoning on each step before moving to the next. What operation was performed? Distributing, adding, subtracting, multiplying, dividing, or simplifying? Did it happen on both sides of the equals sign or just one side? Give an equation. Always start with the given. Every proof must begin by stating the given information, the equation, or the fact provided at the start. This first step requires no operation and no property of equality. You are simply identifying your starting point. Step 1. Ask yourself, was any operation performed or is this just the starting information? No transformation happened here. This is the equation provided to solve. Step 2. Ask yourself, is there a multiplier sitting outside parentheses? Yes. The 3 was multiplied across both terms inside the parentheses, and this happened on one side only, expanding the expression. Step 3. Ask yourself, were like terms added together on the same side, or was something done to both sides, and were combined on the left side only? Nothing happened to the right side. Because only one side was rewritten, this is not a property of equality. Step 4. Ask yourself, was the same value removed from both sides to keep the equation balanced? Yes, 18 was subtracted from both sides. Both sides changed by the same amount, so equality is preserved. Step 5. Ask yourself, were both sides divided by the same number to isolate the variable? Yes, both sides were divided by 9. This isolates while keeping the equation balanced. Think. Practicing a simple proof. Here is a two-step equation that has already been solved. Match each transformation on the left to the property of equality that justifies it on the right. Given 2x plus 6 equals 18. Match each step to its correct property of equality. Practicing a multi-step proof. This proof has 4 steps, each one a different property from your toolkit. Match every transformation to its correct justification. Given 2x, 3 equals 5x, 15. Match each step to its correct justification. After completing both matching activities, reference the complete proof below. It shows the same reasoning applied to the walkthrough equation, with every justification named. Step equation. Justifying a transformation. Think. Justifying a transformation. Apply what you've learned to identify the property that justifies each transformation. Which property justifies this step? Given. Next step. Which property justifies this step? Given. Next step. Spotting the error. A student solved the equation and got the right numerical answer, but made a logical error in one of the justifications. Read the student's work carefully, then answer the questions. Given equation. Step equation. Student's justification 1. Given 2. Distributive property 3. Addition property of equality 4. Subtraction property of equality 5. Division property of equality. Which step contains the justification error? In your own words, explain why the justification is incorrect and write the justification that should have been used instead.
If you need supporting materials, additional resources, or helpful links related to any lesson, simply scan the Instagram QR code displayed on the screen and send us a DM. We will be happy to share the resources with you. And don't forget to follow our Instagram page for updates, learning resources, and future content. Thank you.